All right, welcome back everybody. So we are going to be working on electron configuration. Now this is going to be a little bit of a shorter video because there's a lot more to this, but I'm simplifying it down by saying memorize the overall layout of the electron configuration for now. I'm going to put an asterisk. We're going to talk about how to do this without having to memorize it and only using the periodic table, but that'll be in a later video or a later class. Okay, so let's break down what just electron configuration means because we're starting to get to these really big words, right? So let's break it down, try to make it a little bit more simplified. So electrons referring to the subatomic particle, and configuration meaning to how those electrons are configured in an atom. So as we said in our last video, we talked a little bit about how an electron can move in a single electron atom. We talked about how it could move up and down and absorbing or releasing energy in the form of light. But with multiple electron atoms, they all need to be configured in the shells within orbitals. All right, so if we start off with this configuration, you are to be expected to know where these electrons are going to go just based off the number of electrons each element has. So for example, carbon. So if we go to periodic table, and the carbon element has 6 protons. And again, on the periodic table, everything is considered neutral. So 6 protons means that there's 6 electrons. So if we have 6 electrons, I'm going to write 6 electrons here, and I'm going to fill them in. So if you remember, we want to start from the bottom and then go up. So I have 1, 2 in my 1s, and then I have 1, 2 in my 2s. And if you remember, with 2p, they're all the same energy, so I'm going to put 1 in each first. So 4, 5, 6. So my electron configuration would be this configuration. This is the two-dimensional version of my electron configuration. Now, let's convert this into a one-dimensional electron configuration. So we know that we have electrons in our 1s orbital, right, 1s here, and then we know we have electrons in our 2s, and then we know we have electrons in our 2p, right? But we don't know exactly how many there are, especially with 2p where this is a little bit more important. So with our 1s, we know we have 2, so the asterisk at the top refers to the number of electrons inside of that 1s orbital. 2s, we know we have 2 as well. And our 2p, we happen to have 2 as well. Okay. Now that is not always going to be true. This is carbon's electron configuration, and this is always going to be its electron configuration unless it's excited. Okay, if it's excited, then electrons will move up and down depending on where the light hits and things like that, but that's for another class. So I want you to try this exact same process, but do it with boron. Okay, so let's work with boron for a second. So again, go to the periodic table, find out how many protons or electrons, they mean the same thing on the periodic table, how many electrons boron has. All right, boron has 5 electrons. All right, so again, we start from the bottom. 1, 2, 3, 4, 5. So how would this translate to boron? Again, we have electrons in the 1s, we have electrons in the 2s, we have electrons in the 2p. We have 2 electrons in the 1s, we have 2 electrons in the 2p, but we only have 1 electron, 2 electrons in the 2s and only 1 electron in the 2p orbital. Okay? Now what I want you to do is take some time and do the exact same process, but with each of these. Now again, we may fill up all the way through our 2p, but we know what's next, which is 3s and 3p. So feel free to use these as your templates to answer these questions. So write down again, every element has this configuration of orbitals. However, if they're filled or not is the question. So I'll go ahead and write down the answers, but take your time if you need to. So do a hit pause here if you want more time to practice with these electron configurations. So pause me, practice them, right? Don't just listen to me. All right. Okay, so the electron configuration for oxygen is 1s2, 2s2, 2p4. The electron configuration for helium is 1s2, 2s2, 2p6. The electron configuration for calcium is 1s2, 2s2, 2p6. This one may be a little bit tougher for us. 2p6, 3s2, 3p6, and then this one's the tougher one. The next one would be 4s1, or sorry, 4s2. Okay, magnesium. Magnesium would be 1s2, 2s2, 2p6, 3s2. All right, so these are how the electrons are configured in each of these elements. Okay. In the next video, we will talk about how these configurations even occur. Why does it happen this way? And we'll talk about the relative energies of the different orbitals and things like that. All right, everybody. Thank you for joining. I really appreciate you coming. Please hit that like and subscribe button. You know the gist. And we'll start with this tomorrow. Bye-bye.